So we have seen we were varying the input, okay, V input from minimum to maximum, and we are also changing the varying the load RL minimum to RL max. Okay. Now what about the series resistance here? So your circuit is here. This is your circuit. This is your Gino diode, and this is your RL. Now this RS also has a minimum and maximum limit for if you're for given VIE and RL. V input. Okay. Now suppose that the input value and RL value is such that your diode is on. Okay. So once diode is on, automatically what will become? The voltage here will become VZ. Okay. If this voltage is VZ, this voltage is VZ. Okay. And the voltage across this R, BR, the voltage across the resistance is will be given by VI minus VZ upon I. If I current is flowing, I, so your I will become, oh sorry, VI minus VZ. Okay, and VR is your what, I into R, VI minus VZ. That means your R is equal to VI minus VZ upon I. Okay, and I can write VI minus VZ. I is nothing, IZ plus IL. Okay. Now VI is fixed, VZ is fixed. Automatically this VR is fixed. Okay. So now what will happen? Now suppose if I start reducing this R. Okay. Okay. So if I decrease the R, if I decrease the R, what will become? My this cannot change, this cannot change, this is fixed. Okay, IL is fixed. IL is fixed. IL is how much? IL is your VZ upon VZ upon RL. This is also fixed. So VI fixed, VI fixed. Okay, VZ fixed. Okay, and then your IL fixed. IL fixed. Now if you keep on decreasing this R value, what will happen? This IZ will keep on increasing. IZ will keep on increasing. Okay. So this R has a minimum value, R minimum value, for which IZ will become IZ max. IZ will become IZ max. Okay. So what I can formula? I can write formula. So I can write the formula for R minimum. I can write this is VI minus VZ IZ max plus IL. Okay. So this is the formula for your RL minimum. Okay. Now you have to keep in mind thing. You have to choose RL minimum R here such that, okay, that it should be safe. Okay, it should be safe. That means it should be independent of IL. Okay. Now, of course, suppose I know VI, VZ, I know IZ max also, I know IL also. Okay. Now somehow if I reduce this RL, automatically what become? My IL will increase. Okay. Now in other words, if I keep this IL 0, if I keep this IL 0, this limit will go up or down. R minimum limit will go up and down. Tell me. If I put IL 0, this R minimum will go up or down?
So up.
Up. Very good.
Up.
So up is more safe. Yeah, this is more safe. Which resistance is safe? See, this is the resistance. If I go below this one, my generator will burn out. Okay. So why I should why I should I keep this limit? I should go. I can keep here a little bit more safer. Okay. So what more safer means, if I want to make it independent of IL. Okay. So that the effect of I should not come here. See, this can increase only when this can decrease. Okay. So I am making it 0 so that my RL will go, IL limit will go more safe resistance. Okay. So in general, if IZ is max, IL is fixed, you can use this formula. Sometime in the question, IL will not be given. Okay, that time also you can keep your RL minimum equal to VI minus BZ IZ max. You can use this limit, RL minimum. Okay, so this is the formula for R minimum. And there's one more formula for R minimum. Suppose this VI is varying. VI is varying from VI max to VI minimum, and this RL is varying from RL max to RL minimum. Okay, or you can say IL minimum to IL max. This is also varying. So in that case, what should be the limit of R minimum? Okay, so R minimum is the value, always value, when this should become IZ max. So you can always use this formula, R minimum. Now if you want to make R minimum, okay, so R minimum should counter this VI max also in a circuit. If you are putting some R for this VI max, automatically this R will work for this one also. Okay, because if suppose this is a fixed, okay, and this is varying, VI is more, so automatically here current will more. See, here voltage will be more. If VI is more, voltage will be more. Voltage will be more means current will be more. Okay, so current will be more means current here will be more. So your R should be such that we should encounter this VI max here. Okay, so what I'll do, whenever this formula is very clear, if the circuit is given. Okay, now in the circuit, if this is given, V input varies from max to minimum, and R minimum, R also varying, or IL also varying. In that case, you can put the formula for R minimum equal to VI max minus VZ. Okay, this minimum, so IZ max plus IL minimum. This is the formula. Okay, and or if IL is not given, you can use this formula also, R minimum VI max minus BZ IZ max. This formula you can use directly. It is the upper limit of R minimum. If you use this R minimum, it will work for everything. VI minimum automatically, it will work for VI minimum. It will automatically, it will take care of changes in the circuit. Okay. Similarly, if you say that what is R max? R max. Okay. What is R max? Suppose this VI is fixed. Okay, this RL is fixed. Okay, so R max will be what? R max will be your Vi minus Vz. Okay, first I will let R. Okay, IR. So here will go I. Now what will happen if I increase this R? What will happen? This I will decrease. This is fixed. Now keep on increasing this one. This I will be keep on decreasing. Okay. Now this RL cannot change. RL is fixed. So automatically this IZ will decrease. So the formula for R max is Vi minus Vz IZ minimum plus IL. This is the formula for your, because IZ minimum, if you keep on increasing the R, this is fixed, this will keep on decreasing, and a condition will come where the current will be less than the IZ minimum, then automatically what will happen? Automatically the diode will turn on, turn off. Okay. So this is the formula also you should remember. And this formula also can be written for variation of here and here. Okay. So you remember one more formula, R max. If it is a max, it is a minimum. Here, V minimum. If the limit is given, V minimum minus Vz, and then you have what? IZ minimum. IZ minimum plus IL, whatever IL given, and you can also use, of course, it is a minimum, it will be max, and you can also use this formula equal to Vi minimum minus Vz. If IZ minimum you don't know, you can simply take IL max, the formula. Okay, so when here is max, okay, here is max, IL max, okay, Z minimum. You remember this formula. When this is max, this is minimum. When this is a minimum, this is max. When this is a max, this is a minimum. When this is a minimum, this is a max. That you remember. This minimum minimum max. Okay, and this will be automatically remaining. If it is a minimum, this will be max. If this will be max, this will be minimum. Like this, you can remember the formula and you can apply the questions. Okay, so let me tell you some questions how it comes in the exam. Should I erase this one?
No, sir, please wait for a while.
Hmm.
Sir, done.
Hmm. So you have been given a question, say this varies minus 20 RS 6.8 volt. Okay, this is your, and IL also given. IL varies from 5 milliampere to 20 milliampere. Okay, so asking what is the value of RS max? What should be the value of RS max for this question? Okay, and then they have given you the options. Option A is 390 ohm. Option B is 420 ohm. This is max limit. Okay, that means your resistance should be the less than the max limit. And then C is 440 ohm and D is 460 ohm. Okay, now you want to get the RS max. Okay, so I told you what is RS max. For RS max, you always remember you have to take Vi minimum. Vz is fixed in this limit, and You have to take when RS is max, IZ is minimum, and IL is max. This you have to remember. This is the formula. Okay. Now one more thing here. If the question IZ minimum is not given, if IZ minimum is given, then you can exactly get the value of RS max. Okay. If the question is given, then you can exactly get the value of RS max. But if this is not given, then your RS max limit will go slightly higher. So your actual resistance will be less than that resistance. Okay. So you can write here RS max VI minimum minus VZ. I put IZ minimum 0 is not given in the question. Minimum value always you can put 0. You can write IL max here. Okay. Now everything is given to you. VI minimum is 15 for you. Okay. VZ is 6.8 and IL max is 20 milliampere. Okay. Tell me how much answer is coming. So this is 2, 7, 8.2, 8.2 thousand, and this is 20. Okay. So this cancel 2, and this is 8.2 means what? 8.2 means what? 4.1 and 100. So 410 ohm. So RS max limit is, when putting Z minimum 0, I'm getting 10. That means actual limit is less than this one. So this is RS max value. That means your R should be less than these values. So out of this 4 option, which is the less than? Option A. So this is the correct answer. Okay. So I hope you understand these formulas. Okay, very easy. Okay. So you should learn how to apply these formulas. Now, one more questions I'm giving you. Shall I erase this one?
Yes.
Okay. Now you have this one. 22 to 30 volt is given. RS this will be 12 volt. Of 140 ohm to 10 kilo ohm. Okay. What is RS max for this question? Okay. What is RS max? So RS max formula is what? RS max will be the voltage so you have this V input minimum minus VZ is fixed, and then RS max means you have to take IZ minimum plus IL max. Okay. So here IZ minimum I can take 0 always. So I can take VI minimum minus VZ IL max. So VI minimum minus VZ IL max is your VZ upon RL minimum, because VZ equal to VL RL minimum. Okay, so VA minimum is 22 volt. Okay, VZ is your 12 volt, and RL minimum, and again VZ up divided by VZ is 12, and RL minimum is your 140 ohm. Okay, so this will give you how much? 12 minus 10 and 1400 upon 12. Tell me how much is coming.
116.6.
Yes, 116.67. 116.67 ohm. Okay, is that clear to everyone? This option. Okay, so you should know how to apply the formula.
Sir, please wait.
Mhm.
Done, sir.
Mm. Now let us do one or two problem more. You have been given 5 volt to 20 volt. Okay, and you have been given the diode. Resistance is 2 ohm, and then you have a here 1 kilo ohm load. 1 kilo. And VZ return voltage is 10 volt. Okay, so you're asking what is the value of P max and P minimum across the load. Okay, so you have to find the ratio of P max to P minimum across load RL. Okay, you have to find the P max and P minimum ratio. So P max will be when P max value will when will be P max and when will be P minimum? Tell me. What is the value of P max and P minimum? So if IL is low, that will P minimum. If IL is max, it will be P max. Okay. So first of all, we see if I'm applying this 5 volt, then what will happen? How much is the current here? Okay. And then when I'm applying 20 volt, when is the current is what is the current? Okay. So that will be your that is the only case will be max and minimum because nothing is other thing is varying. Only this is varying. Okay. So if I apply 5 volt here, tell me diode will be always obviously off. Okay, because 5 volt cannot make this diode open. Minimum V open required is how much? V open is value will be how much? Tell me. Minimum V open value. So if I keep V open, okay, minimum V open should be equal to VZ, and that should be equal to VI upon R plus RL into RL. This should be the minimum value of VI. So this gives you VI. VI should be this is 10. R plus RL is 1 kilo ohm and 1500 ohm, that is 1500 ohm. Okay, upon 1000 ohm. So this cancel out 2. So VI should be minimum 15 volt. Okay, should be equal to or greater than 15 volt. 15 volt. Okay, so VI should be greater than equal to 15 volt in order to make this Zener diode turn. So obviously when this is a 5 ohm, okay, 5 volt, this will not turn on. Okay, so once this is not turn on, the current this will be open for 5 volt. For 5 volt, this will be open. Okay, and the current in the circuit IL minimum, this current will be IL minimum. Okay, because now here voltage is how much voltage is there with this 5? Okay, if I keep 5 volt, then here voltage will be less than obviously than 10 volt. Okay, obviously then 10 volts current will be low, so this will be IL minimum. So IL minimum will be how much? IL minimum will be your 5 upon 1500. Okay, that is 1 upon, correct na? IL minimum, what is the value of IL minimum? 5 upon 1500, that is 1 upon 300. Tell me yes or no. Is that correct or not? So in this case, power and load, PL minimum will be IL minimum square into R, RL value is fixed. So this is IL minimum square is what become 1 upon 300 into 300, and RL is 1000. Okay, so this two value cancel out, this one is cancel out. So how much it is coming? 1 upon, tell me how much coming? 1 upon 90.
Yes, sir. 1.90.
Sure, or something I'm missing?
So
One up-
power is IL into VZ.
No, here voltage is not VZ na. Here
Okay.
here is PL minimum na. So this is IL minimum. Yes, I'm doing some mistake values. Why it's coming like this? 500, 1 kilo ohm. Okay. Okay, keep it like that. We'll check whether what mistakes we're doing. 10 by 3, 100 by 9. So this is what? This is in watt. Okay, this is in watt. If I want to keep it in milliwatt, how much will come? Milliwatt will come 1000 upon 90. Okay, so now it's correct. It is 100 upon 9. Either you keep like this or keep like this. Both are same thing. Now, yeah, is that clear up to here? Or I shall explain. Is the point is clear up to
Clear,
here?
sir.
Now PL max. Now second case here, if I put 20 volts, okay. So I have seen we have seen if the voltage is 15 volt, then this will become conducting. So automatically once this is conducting, okay, this will be your 10 volt. So here also voltage will be 10 volt. Okay, when anything is greater than 15, in that case you can find the PL max directly. PL max is your VL square upon RL, or you can find IL max also. Okay, so this is the VL max value. Okay, this is your VL max value upon RL, because VL max only can be up to 10 volt. Okay, that's you should remember. Okay, so VL max is 10 volt. That become now 100. This become 10 volt. That means 100. And RL is again 1 kilo ohm. 1 kilo ohm means this is 1000 ohm. 1000. So this will give you how much? This will give you 1 by 10. 1 by 10 what? 1 by 10 what? Okay, the ratio you can find now easily. So P max upon P minimum.
सर
हाँ,
सर जब हम बैटरी से 5 वोल्ट सप्लाई कर रहे हैं तो तभी तो हमारा कुछ करंट जो लोड है उससे उससे जाएगा, तब हम उसको वीएल मिनिमम नहीं लेंगे।
भी जब 5 वोल्ट लगा रहे हैं तो यहाँ पे जो वोल्टेज ड्रॉप आ रहा है वो 5 वोल्ट से कम ही आ रहा है, ठीक है नहीं? ठीक है,
हाँ सर।
तो यहाँ पे जो और तो अब अगर मैं वोल्टेज बढ़ाता जाऊंगा, यहाँ पे वोल्टेज बढ़ता जाएगा।
नहीं सर, मैं कल से पीएल मिनिमम के लिए पूछ रहा हूँ मैं।
हाँ, मैं प्ले मीनिंग तो बता रहा हूँ। भी अगर ये 5 वोल्ट है तो यहाँ पे ये ऑफ है,
हाँ सर।
तो सारा करंट जो करंट यहाँ जा रहा है वही करंट यहाँ पे जा रहा है।
हाँ
ठीक है। तो अब वो हम अब जो 5 if it is 5 volt, the voltage getting divided here and here. Yes or no?
हाँ हाँ सर, मैं सेम, हाँ सर, हाँ सर, हाँ सर, हाँ सर।
तो वही तो किया ना मैंने यहाँ पे वोल्टेज निकाला और तो अब if I putting 6 volt, here voltage drop will be more than the 5 volt. Yes or no?
यस सर।
So that means 5 volt is the minimum. For 5 volt this value is the minimum ना?
हाँ सर, बट सर हमने तो 15 लेके किया था,
कौन सा 15 लिख किया था? 15
मिनिमम के लिए।
15 कहाँ गया? 5 ही लिया था, 15 कहाँ लिया था?
नहीं, वो 5 तो कल से उसके अक्रॉस था, जो डाइट का अक्रॉस।
अरे मैंने 5 ही लिया था, 15 का नहीं था। विदर यूज मैंने 5 ही तो लिया, कहाँ 15 लिया है? देख नहीं रहा? 5
ओके
तो लिया
ओके ओके सर।
5 तो हम चेक करने के लिए, 15 तो चेक करने के लिए कि किसके ऊपर वो 10 हो जाएगा। ठीक है।
ओके सर।
So now that we taken PL max. Okay. So ratio is 1 by 10 into 9 upon क्या 100 upon 9, 9 upon 100. करेक्ट? कितना आएगा रेशियो? और दिक्कत कर रहे हैं हम लोग। ये आया 1 by 10 and 1 by 90. So 1 by 10 and 1 by 90. So ratio will come 9. That's the answer. Okay. तो इसको if you don't understand this one, you can directly calculate PL minimum like this. PL square upon RL. Okay. So VL square minimum and VL minimum will be when you are applying 5 volt, that is 5 upon 1500. Okay. That is 1 upon into 1000. So this is your 2 cancel, 1 cancel, 3. So 10 by 3 is basically your VL minimum. Okay. And if you put this value, you will automatically PL minimum equal to 190. So minimum value is 10.3. Shall I go to next question?
Yes, sir.
So the next question is, you have been given 500 kilo ohm. Okay, and this is your 30 volt. And this is your Zener diode with 20 volt. And this is your 1 kilo ohm, which has 10 volt. And here you have 2 kilo ohm plus minus. Okay. Now I want to know what is the VL here. Okay, find V load. Okay. So our first job is to find. Now there is a 2 Zener diode. Okay. So 2 Zener diode circuit is basically used to provide more control, more. Okay. With the one power supply, you can do regulation. If a 2 is there, you can do better regulation. Okay. Because if you have voltage there, if this is regulated, okay. So this is more regulated compared to this one. If there's some fluctuations comes, okay, may come, but this is regulated, so their fluctuation will be less. So this will be further regulated here. Okay, so this is a double regulation. So now suppose if I want to now I want to tell what is the voltage here. So for that I should know whether this is on or not on. So whenever there are more than 2 diodes are there, and you have to find which diode is on. Okay, so you have total 4 cases. Okay, say this diode D1, this diode D2. Okay, so D1 and D2, okay, both can be on. D1, D2, both can be off. This is the first case, this is the second case, and there's a third case. Okay, D1 off, D2 on, and the fourth case is what? D1 on, D2 off. These are the 4 cases you have to check. Okay. So once it's easy, once you have the practice, you can immediately tell without checking also. But that the procedure is this one. So suppose I'll start that both are off first. I'll say both are off. Okay. So if both are off, so what will happen? This is also off. This is also off. Both are off. Okay. Now check the voltage at this point and this point. How much is coming? Tell me what is the voltage here and what is the voltage here and here? Tell me. Say I say this A and say this is B. Okay. What is the voltage at VA and what is the voltage at load B? VB. Tell me what come. So this is VA, VB. So automatically this is 500 ohm. Kilo ohm. Kilo ohm. Kilo. 500 kilo. 500 kilo ohm. Should be kilo or ohm. Give it ohm first. And tell me what is voltage V at VA and VB. So you have total resistance how much? Now both are off. This is a 500, this is a 1 kilo ohm, this is 2 kilo ohm, that is 3.5 kilo ohm. So current in the circuit will be how much? 30 volt upon 3.5 kilo ohm. And if I find the voltage drop across this 500 ohm, okay, how much will come? Tell me. 30 upon 3.5 into 10 raised to power 3. Okay, so 500 power 2 cancelled. 1, 2, 15. Okay, I'm calculating voltage across 500 ohm. Voltage across 500 ohm. How much is coming? Drop, voltage drop 15 upon 3.5. Tell me how much is coming. This is 150 upon 30.
4.28.
4.28. Okay, so that means what is the voltage remaining here at what node A? Node A, what is the voltage? It is more than 20 or yes or no? How much coming? Tell me how much coming?
4.28.
4.28. Okay, so this is 30 and 4.28 here. You if you spend here, how much remaining? So remain your 30 minus 4.28. How much?
25.7.
27.
5.7.
That means this voltage is greater than 20 volt. Yes or no?
Yes, sir.
That means this cannot be this cannot be off. Okay.
Hmm.
Similar, okay, and so this cannot be off, so we have to make this on. Okay, now, and what is the voltage coming here? Tell me what is the voltage coming here. So your current, so the first case is wrong. Okay, first case is wrong, you can check it here. First case is wrong if both cannot be on. Okay, so you can keep a one on and one off. So if I say this is on, if I say this is my on, so this is on, so this has become 20 volt. 20 volt. So you can check again if you do it 20 volt. If here is 20 volt, okay. So here voltage will be obviously greater than 10 volts. So this 20 volt will divide here and here, 3 kilo ohm. So this 20 volt will be divided between 3 kilo ohm. Okay, and if you find a drop across 1 kilo ohm, it comes out 6 point something, and 20 minus 6 point something, again 14 point something is coming here. So if this is on, this cannot be off. Are you getting what I'm saying? You have to check all the cases. First case, remove both the things and find the current and find the drop here, how much voltage is coming here, whether it is greater than 20, find the voltage here, whether it is greater than 10. So that means these cannot be off. Okay, similarly I'm keeping this off, this on, but when I'm keeping this on, this voltage become fixed 20 volts, and this remaining 20 volt here, this will be distributed here and here. So I'm finding if this will distribute here, this is greater than 10, so this can also not be off. Okay, and the third case is I say this is on, so here voltage is 10 volt, this here voltage is 10 volt. So now if this is 10 volt, remember out of 30, 20 will be distributed here. Okay, so this is 1 kilo ohm. So I can find here, if this here and here is getting 20 divided. So tell me what is the voltage here? Can you tell me what is the voltage here? So 20 should be divided between here and here. Just 1 minute. One is 30. So if I divide now this 30 here, 20 here and here, so what become? I'll get
So 23.33.
यहाँ पे 23.33 आ रहा है ना?
Yes, sir.
तो ये भी ऑफ नहीं हो सकता है, ठीक है? So the only case here possible is both D1 and D2 are on. Both D1 D2 on. This is the case. This is also on. This is also on. This is 20 volt and this is 20 volt. Okay. You have to keep all the cases and you find that both are on. 1 kilo ohm and this 2 kilo ohm. Okay. So once both are on, automatically this voltage is 10 volt. 10 volts. So you can find IL IL very easily. VL is your 10 volt, and IL will become your 10 volt divided by 2 kilo ohm, that is 5 milliampere. This is the answer. So you have to check everything. Is there any student who are unable to do this one? Tell me, I will repeat again. Clear?
Clear, sir.
So let us now next topic. Okay. So we'll come back to the Zener diode again when I will use it again in some circuits. Miss many it will use many times Zener diode. Okay. So we'll come to that. Okay. Now I am going to other application, diode clipper circuit. Diode clippers and clampers. Okay. So first we'll discuss diode clipper circuits. Okay. So what is the job of clipper circuit? Some part of the signal, some portion of the signal, okay, some portion of the signal will be clipped, will be clipped. So signal ka some portion, either it will be removed. Okay, that means the signal will become distorted. Signal, okay, output signal is distorted. Output signal is distorted. Distorted means whatever compared to input signal, it will change. Okay. Now the familiar example of clipper circuit is rectifier, half wave rectifier, full wave rectifier. Okay, so if you have a source, okay, you're keeping a diode here, and if you are measuring the voltage across this load RL, okay, this my V input is equal to Vm sine omega t. So if you have been given like this, V input, that is Vm omega t. So your V output here will be what? So for positive cycle, for positive cycle, okay, voltage drop Vd is 0, short circuit, diode is short circuit, diode is on. For positive cycle, diode is on. Okay, that is, it will be replaced by a short circuit. That is Vd is 0. So your V output will be almost equal to V input. So you get exactly like this for positive cycle. For negative cycle, okay, diode is off. If diode is off, then what will become? No current will flow in the load. Okay, so your V naught is equals to 0. V naught equals to 0. No current will flow, so V output will become 0. So all the voltage will go across the diode, and Vd will be equals to minus Vi, reverse bias for negative cycle. Okay, for negative cycle here will come minus Vdi minus this one.
सर
Hmm.
सर नेगेटिव में तो वो ओपन हो जाएगा ना?
हाँ, डायोड ओपन हो जाएगा ना, तो वोल्टेज तो रहेगा ना तभी. डायोड ओपन हो गया,
तो लोड में हमें आरएल में कुछ मिलेगा नहीं ना? आरएल में कुछ नहीं मिलेगा नहीं ना?
आर जीरो मिल जाएगा, तभी तभी तो जीरो लिखा मैंने, वी नॉट जीरो.
अच्छा हाँ, बी डी इक्वल टू बी आई, यस यस
हाँ, Vd इक्वल टू माइनस Vi.
यस यस, फिर ठीक.
सेकंड साइकिल में करंट ऐसा उल्टा फ्लो होगा.
यस 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 यस
ओके, हम जैसे मजे कर रहे हैं, करंट ऐसा फ्लो होगा.
यस, थैंक यू सर.
So the circuit is like this. So the negative portion has been clipped. This portion is clipped, removed. That's why it's a clipper. This is a clipper circuit. Okay. Now let me modify this circuit a little bit more. So this is one example of clipper.
So just a second.
Yeah. Okay. So now next circuit. So next circuit is what? Next circuit, I am putting resistance here and diode here. Okay, I'm taking V output here, and this is Vi. Vi equals to Vm sine omega t. This is my R. Okay. So tell me what will happen now. So for positive cycle, diode is on. That means replaced by short circuit. So voltage across diode, this time it is a Vd is equal to V naught I'm measuring like this. V naught equals to 0. Yes or no?
Yes, sir.
So this circuit, what will happen? This portion will be removed. Okay. For positive cycle, okay. I'm making VD here. VD like this. And next cycle, next cycle, what will happen? Next cycle. For negative cycle. For negative cycle, my V naught, okay, this will be off, no current will flow in the circuit. So my V naught will become equal to
V.
Vi. But you have to keep one thing in mind. So if Vi is negative, now V output will be also negative. Because now this whole Vi, whatever is coming, will come here. But this is a negative, the negative cycle. Okay. So output will be also negative. Are you getting? This voltage become parallel to this one. Now if it is -1, it will become -1. If it is -2, it will become -2, -3, -3, -4, -4. That's why I say Vi equal to V input. Okay. So whenever we plot the relation between a V output and V input, okay, that is called transfer function. That is called transfer function. Transfer function. Transfer function is what? Here I am putting here sine wave. It is not necessary it should be sine wave. It should be any general V input. Okay. In that case, what will happen? If I am putting these positive values, okay. If this is a ideal diode, this is ideal diode. This diode is ideal. So now what will happen? If I put any value, this is my V output and this is my V input. Any positive value, I won't get any current for this circuit. My circuit will give positive values. My circuit will give you 0 voltage. Okay. And if I apply negative value here, so -1, -2. If I apply -1 here, it will come -1 here, -2, -2. So this graph will come like this. Okay. So V input can be sine wave, then this is the graph, but it may be anything else, which can have a positive or negative value. So in that case, the graph will be like that. So this is all. So plotting the graph like this is an advantage. So if you can plot like this, then later plotting this is very easy. The function can be anything, sine wave, square wave, and triangular wave. So you should know how to draw this one. If you know drawing this one, positive, negative thing, then you can see and you can draw exactly like this. So positive it is 0, you put positive 0. Negative is exactly same, like same V input, you put exactly like a same input. Okay. The last circuit. For the last circuit, what is the plot? Okay, last circuit, half wave rectifier. Half wave rectifier. If I plot this curve, same curve, so we see what we have seen. For positive cycle, we are getting exactly V output equal to V input. And for negative cycle, we are getting 0. So you can put this graph in previous one. V output 0. So here V output is equal to V input. Here V output equals to 0. Okay. Now I'll change the circuits more and you to tell me how the graph will look like. Should I erase this one? Okay. So say now this time what I'm changing, say this is my silicon diode. This is my silicon diode. Okay. So tell me now what should be the graph between V input and V output versus V input. So if I'm applying some V input here, say 0.1, V input is 0.1. So what is the voltage value I get? Tell me. What is the voltage I will get here? If I'm applying, I'm first plotting the transfer curve. If I'm applying 0.1 volt, this requires 0.7 volt. So how much voltage will come? Tell me.
0.1 volt.
0.1 volt. Because if you apply 0.1 volt, if your V input is less than equal to less than 0.7 volt, okay, so in that case will be diode is off, diode is off, diode is off. That means open circuit, so no current is flowing in the circuit, and no current in the circuit flowing, at least this voltage will automatically come here. So up to 0.7 volt, if you are applying input, okay, your V output will be exactly like V input. Okay, and once you apply 0.7 volt, greater than 0.7 volt, okay, what will happen? This will become on, and this voltage will become fixed. So after 0.7 volt, this voltage will become fixed. 0.7 volt, 0.7 volt, 0.7 volt. That means your V output will be 0.7 volt, okay, for V input greater than equal to 0.7 volt. Up to 0.7 it is on. Okay, up to 0.7 it is off. And once you become greater than equal, you remove up to when it greater than, okay. So less than equal to V input, diode is off. It will be slightly greater than, and greater than become greater, this become fixed. Okay. What about reverse side? This is for positive cycle. This is for positive. This is for positive cycle. Now what about negative cycle? Tell me.
बी आउटपुट को बी इनपुट हो जाएगा.
Very good. For negative cycle, V output will be this will be open negative cycle. So V output will be equal to V input. Now if you're putting V input negative side negative, output will also come negative. Now the same curve you can plot for sine wave. If you're giving sine wave as an input, if you're giving sine wave as an input, is input wave. So your output will be initially up to 0.7 volt. It will increase same like input wave, same like input. Okay, and then it will become constant. So this is the limit 0.7 volt. Okay, here voltage is 0.7, say 0.7. So up to 0.7, when less than 0.7, up to here less than 0, it will be same, and then it will become, when it will become greater, it will become constant. Okay, again it will become same, and then again for negative you get exactly same. So this is 0.7 volt. So this will be the for sine wave, this will be the graph. So by knowing this one, you can immediately plot like this. Okay, if greater than, constant, otherwise same, otherwise down is same, down is same, down is same, down is same, exactly like an input. Okay, so let us do some more circuits to understand what is clipper and clamper. Okay, एग्जाम में इसको मिस्टेक नहीं करना है इसको. So now what I'm doing, second case, I'm just turning this diode. I am putting diode like this. Okay, and this diode is again silicon. Tell me the graph, how it will look like. Tell me the graph. How should it look like? So again, first we have to plot the transfer curve. Transfer curve. Transfer curve means V output versus V input. Okay. So for positive cycle, for positive values, for not cycle, okay, cycle only sine wave, okay, for positive values, okay, diode is always off. Diodes is off, and when it is off, this should be equal to like this. Okay, diode is off. That means your V output is equal to V input. And for negative cycle, okay, if V input, tell me, what should be? Is greater than minus 0.7. Okay. So now for negative cycle, what happens? Negative cycle, this become positive, this become negative. This diode will only conduct, okay, when you are going, okay, when are you going greater than this 0.7. So up to 0.7 here also it is on. If your voltage is negative also it is less than 0.7, okay, less than 0.7, that means this is less than 0.7. So what will happen? Negative 0. So you see negative. If it's less than negative minus 0.7, then also this is off. And once it become uh, greater than 0.7 in the scale, okay, this will become your positive. Negative का मतलब यहाँ पे negative नहीं, negative में cycle change है. Okay, you would only see the magnitude. Okay, after changing the cycle, if this is greater than 0.7 in opposite direction, this will become on. Okay, and you will get the voltage 0.7. Before that, this is on. So whatever voltage is coming, you get this one. Okay, so you can write when V input for negative values, whenever V input is less than 0.7. Obviously, this is negative, so your V naught will be equal to V input. Like this, you can write. Or your main thing is plotting. Okay, writing is different. Okay, understanding what is there, and you have to plot minus 0.7. Is this clear? Is this graph is clear?
Yes, sir.
Okay. And now you can plot this graph for sine wave also. This is so for positive cycle you are getting as it is. Negative cycle you are getting like this. Okay. So when you go 0.7 somewhere here, then it will become constant. And after that, this will be like this. Now let us do some more things. So I'm giving you 2-minute break. Water. Come. So let us put now a ideal diode again. You have a circuit plus minus. You have a V input plus minus. Here you have a diode, and here you have a resistance, and then you have a battery VB kept like this. So I am doing all the possible cases. Okay. So you tell me now what will become. It is the ideal diode. This is the ideal diode. Now you tell me what will become the characteristics. This is your V input, V out. Tell me what will happen. For positive value, what will happen?
So this VOT is across like which two terminals?
Huh?
I'm asking this that and this VOT is across
Oh,
what?
this is V output here.
Okay. So
Tell me what will happen. If so, this diode will become forward bias when? When? Tell me. When your Vi is greater than Vb? Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
This Vb is making reverse bias. So if you want to make positive, VIB should be greater than Vb. So if Vi is less than Vb, then this is open. Okay. If it is open, then what will become? What is the voltage here? Tell me. If Vi is less than Vb, okay. Diode is what? Diode is open. If diode is open, okay,
Sir, Vi equal to Vb.
so V naught equals to Vb.
Hmm.
Very good. Because here no current is there, no drop is there. So this point is same, but this battery is there. Okay. I'm measuring here. So I don't matter what happening here. This circuit is not giving anything to this circuit. This will be disconnected. Because this once become open here. But here I can measure, so I get V positive. If it is less than VIB, I get voltage equal to VIB. VB, voltage equal to VB. Okay. And once VI greater become greater than VB, then what will happen? Tell me. Then this drop becomes zero, yes or no? This drop becomes zero, short circuit, diode is on. So you can replace it by short circuit. That means here no voltage drop. So this voltage, all voltage come here, exactly here as it is here. So you can plot like this. Yes or no? Same happens. Same happen for negative case. Negative case, what? How can you draw? Tell me. Negative case. So negative case, always this same thing. For negative case, diode is always open. Okay, already it's making negative, it's open. But more negative, so it's always second. So if this for positive VI, for positive for positive VI, okay. For negative VI, diode is open, always open. Diode is open means always this circuit. So for negative also you get same voltage VB. This is the case. Is this point clear to everyone? Ujjwal, Divanshu, Karishma, is this clear?
Yes, sir.
Yes, sir.
Okay. Now, let me give you one more graph. Now you have to draw that one. Okay. So say a circuit is there, or this diode is there, VB is there, okay, and R is there. Plot here you're playing V input. Plot the graph. How it will come.
Sir,
Ah,
sir, your voice is coming very low.
okay, wait a minute. Yes. Hmm. So please plot the IV characteristics for this graph. Diode is ideal. Yeah, diode is ideal. Tell me, how should I do it? Okay, plus minus V naught. Okay, so this diode is already reverse bias or battery. So anything positive, so it's be always open. Okay, if this become open, okay. So if for positive VIE, okay, if VI is less than VB, diode is open. Okay, diode is open means now this is also become disconnected. It's not connected here. So this is open, no current is coming here. So this voltage is exactly coming here. Okay, so you can write your V output is exactly equal to V input. For what? If Vi is less than Vb, and once Vi become equal to greater than Vb, this will become short circuit. So this voltage will come exactly here. So you can write here. So V naught will be equal to here. V naught will be equal to V input, and here V naught will be equal to Vb. So this will go like this. This is your V output. So V input. So to VB, like the case. Okay. And negative, what will happen negative? Tell me what will happen negative. For negative V input, diode is open or closed?
Open.
Diode is open. Diode is open. So diode is open. That means which case will come? First case will come.
V output equal to V input.
V output equals to V input. Like this. Okay. Let us do it. One more problem. R silicon, this is silicon plus minus Vi. Okay. Here you have a voltage here. Okay. Plot the graph until how it will come. The silicon means 0.7, 0.7. Okay. So for positive cycle, so this is diode D1 and this is diode D2. For positive cycle, okay, which positive cycle when Vi is greater than 0.7. So if for positive cycle, when Vi is less than 0.7 volt, which diode is on? Tell me. Which diode is on?
Both are off.
Very good. Both are off. If Vi is less than 0.7, this is already off. And if Vi is positive, this is always off. This can be on only when Vi is greater than 0.7, but if it is less or equal, this is off. And this is reverse bias, this is already off. So D1 is off. And D2 is off. Both are off. Both are off. So this V input will come exactly here. So this V naught, V input, this V output will exactly come here up to 0.7 volt. And after that, what will happen? If Vi is greater than 0.7 volt, what will happen?
D1 will be on.
D1 will be on, D1 is on, D2 is
Off.
off. So this is not circuit, this become on. So voltage here become fixed 0.7. Similarly for negative cycle, for negative values, negative Vi, okay. This diode is always for negative values, this diode is always reverse bias. If I put negative value, this minus, this plus, this always reverse bias, okay. And this can be on when only your negative value is less than
Greater than less than 0.7.
so it's the same, and when it become equal, it come like this.
Yes, sir.
So you will see both the diode and accordingly you plot the graph. For negative Vi, D1 is always off. D1 is always off. Okay. Similarly, you can write for positive cycle, D2 is always off. Like that, you can put it. Let me give you one more question. So you have a V input. Okay. V input is 12 sine omega t. This is a Zener diode. Or this is a Zener diode. And this is your resistance R. And here you are measuring VL. This is 6 volt. 6 volt. Now we need to plot the graph between This one we need to put the graph. How can we put the graph? Tell me. Can you tell me how to plot the graph between these values? So input is what? Input is your V output, V input, okay, and this is 12 sine omega t. Up to here. 12. Maximum is 12. Okay. Now, in order to diode to conduct, how much voltage it require? 6 volt, because a Zener diode conducts in reverse bias. Okay. So Zener diode conducts in reverse bias. Okay. Zener diode conducts in reverse bias. Okay. So when your this become greater than 6 volt, okay, so when Vi is greater than 6 volt, so once it becomes 6 volt here up to Vi is 6 volt, this Vi is 6 volt, this will become on. So once become this is on, here voltage will become 6 volt, so automatically output will become 6 volt. Okay, yes or no?
Yes, sir.
But if it is less than 6 volt, this is off, so no current will be flowing in the circuit. So what will, so output will become 0. Okay, so if you are less than 6 volt here, this is the limit. If your input is less than 6 volt, okay, if Vi input
Output
is
is
greater
0.
than this one, then V naught is your 6 volt. Okay, but if Vi is less than 6 volt, that case your VU output will be
0.
0.
Yes, sir.
So this is your V output. So V output will become here up to here is 0, and then not then it's not 0. It here becomes 6. Remaining will come here. Then V0 will be your 12 minus V input minus 6. Okay, because here it is fixed. Now you put 7 here, so 7 minus 6, 1 will come here. If you put 10 here, 10 minus 6, 4 will come here. If you put 12 here, 12 minus 6, 6 will come here. So it will go up to here. It will start from here. Okay, and it will go like this, come like this, and here maximum it can go 6 volt. Maximum it can go 6 volt for positive cycle. Okay, and what will happen in the negative cycle? Tell me. Negative cycle, this for positive cycle, correct? For negative cycle, what will happen? Negative cycle, tell me. So negative cycle, what become?
0.
Diode become what as a ordinary diode. Diode is also become ordinary diode. Okay, so what will become? You now just 1 minute hard. So it will come exactly same. If it is come like this, up to here, this part, you're getting 0, and after this part, will exactly like this. Yes or no? Why?
So,
Ah.
please repeat.
So say this for this diode for diode Zener diode is Zener for diode. Okay, voltage is VZ for reverse bias, and for positive cycle, for positive voltage for positive cycle, Zener diode is ideal. Zener diode is ideal. Ideal means now if you are applying forward bias, if you change the if you make the negative cycle, Zener will be forward bias. Okay, for negative cycle, zener will be forward bias, and it's not ideal means it even do not require 0.7 also. Okay, so if it doesn't require 0.7 also, so this becomes short circuit. Okay, so this whole voltage coming here. Okay, this whole voltage coming, that means your V output is equal to V input. Yes or no? So negative cycle, your V output is exactly equal to V input. Now V input is negative, it will also come negative. Tell me it's clear or not?
Yes, sir.
सर नेगेटिव वाले एक बार फिर से करना एक्सप्लेन।
फिर नेगेटिव में क्या हो जाएगा, ये फॉरवर्ड बायस हो जाएगा डायोड। ठीक है, और फॉरवर्ड बायस में ये आइडियल है। फॉरवर्ड में आइडियल इसका मतलब क्या हो जाएगा, फॉरवर्ड बायस में आइडियल इसका मतलब क्या हो जाएगा, ये पूरा का पूरा वोल्टेज क्या आ जाएगा, यहाँ आ जाएगा। ये भी ये शॉर्ट सर्किट हो जाएगा, तो ये वोल्टेज यहाँ आ गया सीधा सीधा। अब ये नेगेटिव है तो ये भी नेगेटिव। और अगर ये सिलिकॉन है, फॉरवर्ड बायस में सिलिकॉन है, तब क्या होगा, तब up to 0.7 again this diode is open, so no current is flowing.
Yes, sir.
Okay, so up to 0. Up to then up to here, then up to here it will come 0 up to here, and after that it will start. Understand? Then you have to wait for up to 0.6 until it comes for 0.7 0 0 0, and when it comes then start here and then like this. Okay, that you keep in mind. This is Gina's. I'll do one more problem. Now you can tell me what will happen. Just I'll put a graph. So say I have a resistance. Say this is 1 kilo ohm resistance. Here I am putting a Zener diode. Here I am putting a, say a normal diode. Here I am putting a normal diode. And here I am putting say a voltage of 5 volt. This requires say 3 volt. Zener voltage is 3 volt. This is also say 1 kilo ohm. Okay. Tell me what is the V output. And say this is 0.7 silicon. Tell me what will become, which will become on, which is off. What is the output? Can you tell me? So you have to check both the cases. Both the cases that if both are on, both are off, one is off, one is off. Okay. If I say, okay, if I say my Zener is say this Zener is on, okay, say this is diode D1 and D2. If say first case, if D1 is on, if D1 is on, then how much voltage come here? 3
3
volt.
वोल्ट 3 वोल्ट होगा ना।
If D1 is on, so automatically this will also become on, yes or no?
Yes, sir.
यस सर।
So if D1 is on and D2 is on, if I make this on, this is automatically on. Okay. Now if it is automatically on, let us check it whether it is possible or not. So if this is on, now D2 is on, this is on, this becomes 3 volt battery, and this is also on, so this also becomes 0.7 solar battery. Okay. Now let us apply this 3 volt will be divided here and here. Okay. Now let us see whether it is possible or not. Okay. So now So this is a 3 volt here. Okay. So tell me what is the current here in 1 kilo ohm? What is the current? So current in 1 kilo ohm, how much it will be there? Tell me. So 1 kilo ohm.
2.7 milliampere.
So current in 1 kilo ohm, current in 1 kilo ohm. Okay. So this will be 3 minus 0.7 divided by 1 kilo ohm. That will become how much?
2.3 milliampere.
2.3 milliampere. Okay. 2.3 milliampere. That means 2 point voltage is loss in here. Okay. And 0.7 here. Now apply KVL in this loop. KVL in this loop. What will happen? Can I apply KVL here? So so here is 2.3, here 2.3 volt, and this one. Okay. Now say, what is the current here? Tell me what is the current here? In this, what is the current here? This is 5 volt, this is 3 volt. Okay.
0.5 milliampere.
No, it is 5 volt and this is 2 upon 1 kilo, 2 milliampere. Yes or no?
Yes, sir.
And this current is coming how much? 2.3 milliampere. So is that possible? Here
No,
this is giving 2 milliampere current, and this is 2 milliampere, because some current has to go here also. Got my point? So this cannot on. This both are the parallel. If I make this on, so automatically this is on. Okay. But if I make this on, this is not necessarily on. So this can be like this. Okay. So this cannot be on. Okay. So what will happen? Whenever I apply like this cases, I only told you in parallel circuits. Parallel circuits, this is your Zener diode. Okay. So parallel circuits, you have to see which will start first, that you have to start. So say 5 volt, this require only, in order to start this one, this only require voltage greater than 0.7 volt. If your voltage is greater than 0.7 volt here, this will start. 0.8 volt also it will start, 0.9 volt also start. And this require 3 volt. That means this branch require lesser voltage. So this voltage will be, this will be always off, and this will become on. Okay. Now you can find what is the output. Okay. Now you can use this is a single loop. Okay. So current in the branch will be how much? I will be 5 minus 0.7 upon 2 kilo ohm. That is 4.3 volt upon 2 to 10 to power 3. How much milliampere will come? Tell me. How much milliampere? 21.5. 21.5 10 to power minus 4. Okay. That is 2.15 milliampere current is flowing. So 2 milliampere current voltage it will come here. So V output will be IR I into R plus 0.7. I is 2.15 milliampere. This is 1 kilo ohm plus 0.7. Okay. This cancels out. This becomes 2.15 volt plus 0.7 volt. How much become 2.7? How much? Tell me. 2.85. 2.885. And this is the answer. Okay. So always start the diode. Okay. Which has a lesser, which require lesser voltage. If this question is clear to everyone, it's a very important question. Okay.
yes, sir.
So if anybody has doubt, please you can ask me. So this concept you have to remember. So if you know this concept, then I don't think any tough problem come in exam for Clipper. Okay. There's a one or two problem more for clipper. We'll do tomorrow. Okay. So that is your thing. Okay. Let me do one more. This is the last one. Zero point 0.7 volt. 0.7 volt. This is your V naught. Find that transfer curve for this graph. So here I'm applying V input, okay, plus minus. Okay. Say this diode is D1 and this diode is D2. Okay. So diode D1 is reverse biased. Diode D1 is reverse biased by 1 volt and diode D2 is reverse biased by 2 volt. Okay. So for first we'll start positive cycle. For positive VIE. What happens for positive VIE? So positive VIE, diode D1 is always off. D1 is always off because this is already reverse bias. We're putting more reverse bias. Okay, this will be always off. So, and D2 can be on only when VI is okay. D2 is on. D2 is on when V input is greater than this 2 volt, greater than 2 volt. That means up to 2 volt. Okay, both are this also off, this also off. So when both are off, this voltage automatically will come here. So up to 2 volt.
So 2.7, no?
2.7, sorry, 2.7. No, what 2.7? Ah, you require this 0.7 also. Very good. So this is also always off, and in order to make this on, this you have to apply 2 volt plus you have to apply this 0.7 volt also. If you want to make it on. Okay. So up to 2.7 volt. This will be always on. It will be always on. Okay. Up to 2.7 volt. And this will be always on. And after that, once it is greater than 2.7 volt, it will voltage will fix to 2.7 volt. Tell me what about negative? Negative में क्या होगा बताओ? For negative VIE, D2 is always off. Okay, D2 is always off, and D1 can be on only when you apply voltage greater than 1.7. Okay, D1 is on. D1 is on when V input is negative value. Okay, greater than 1.7 volt. Okay, so here up to 1.7 volt, it will be like this, and this become like this, 1.7 volt. Okay. So between minus 1.7 to 2.7 volt V input value for V input, and V input is between these two inputs, your V output is equal to V input. ये क्वेश्चन में पूछते हैं कि किस रेंज में, in which range your V output is equal to V input. So these two ranges, V output is equal to V. If this point is clear, this question came in gate EC. So I'll stop here. Tomorrow we'll meet with more problems. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.